To begin Chapter 7, we're going to start talking about exponents. And there are a lot of rules about exponents that you already know. So we just have a few things we're going to add to it. In particular, zero and negative exponents. And then we're going to review all the other properties throughout the chapter, including our scientific notation, where it's most often used. So we're going to talk about zero and negative exponents. First thing I want you to do is think about what's going on with this table. So we're going to try and fill these in and copy and complete the table, make sure about how the value of each expression, exponential expression, an expression containing an exponent, changes when you decrease the exponent by 1. So what do you think the value of 5 to the negative second is, and explain your reasoning. So there's a couple things we want to do. So probably 2 to the first power is the easiest place to start. We know that's 2. 2 squared is 4. We notice that's going to be times 2, so this is 2 times 2 times 2, so that's going to be 8, and this is then going to be 16. If I start here, I have 10. I'm going to multiply 10 times 10 to get 100. 10 times 10 times 10 will give me 1,000, and then we'll have 10,000 as 10 to the 4th. And the reason I wanted to start with something you know, so we can work backwards. Well, 8 is how much of 16? It's half of it, right? I'm dividing by the base number 2. Divided again, divided by again. So what is 2 divided by 2? Well, your answer is 1. What is 10 divided by 10? Your answer is 1. What is 1 divided by 2? Well, that's 1/2. What is 1 divided by 10? Is 1/10. Now, if you do this on your calculator, you're going to notice this says 0.5. And you notice this one says 0.1. And those are true. That's exactly true. What we want to do is try and avoid using a calculator for this and try and come up with the actual idea. So, the other connection I want to make is 1/2 is the reciprocal of 2. Right? This is 2 over 1, so 1 over 2. So what we're really doing is we're taking the reciprocal. So if I know what 2 squared is, which is 4, I know 2 to the negative second power, negative square, is 1/4. So 10 to the negative second is going to be 1 over 100. So I have two major ideas here, and I kind of weave them together, not to confuse you, just to try and get it all pointed out here. Number 1, anything to the 0 power is 1. Okay, so here's rule number 1. Our second rule is that if I have any number, let me spread this one out. So 2 to the negative first, remember this is over 1, is equal to 1 over 2. And this would still be to the first power. So the question over here, what pattern do you see as you complete the 2 to the x column? Well, we noticed that it was divided by 2 each time. We notice in 10 to the x that it was divided by 10 each time, because we're using that base at our base number of 2 and 10. So we have to get back to this. What do you think the value of 5 to the negative second is? Well, I know 5 squared is equal to 25. So if I'm going to use negative second, I'm going to take the reciprocal and say 1 over 25. And these are all going to be definition items. So this is something we have to ingrain in there. So again, the first rule we have, anything to the 0 power is 1. Anytime we have a negative exponent, we're going to take the reciprocal and then take care of the power. So if we were going to take, let's say, 3 squared, but let's take it to the negative second. Well, I know 3 squared is 9, and this negative sign tells me to take the reciprocal. So it's 1 over 9. We're going to practice that a few more times. Now everyone in here could tell me that 9 squared is going to be 81. But I don't want 81 because I have a negative exponent. So I have 1 over 81. In between, I might write 1 over 9 squared, because that negative exponent tells me to take the reciprocal of what we have. It is currently over 1. What is the simplified form of each expression? So for b, negative 3.6, and it's all going to the 0 power. 1 So if I have 4 to the negative third, so first thing is I should have the reciprocal of that. Well, 4 to the third power, what you'll find is 1 over 64. Now we can also apply this, as we look at it, to any expression. So instead of just having one single term, we're gonna do a little bit more. So if I have 5 to the first power, a to the third power, but in this last one I have b to the negative second. Well, I can't actually get this number because I don't know what b itself is, but I do know that the reciprocal of b to the negative second will be 1 over b to the positive second. So as I simplify this, 5 and a, these bases have positive exponents, so they're going to stay put, but b with its negative exponent has to be moved to the denominator. So what's the simplified form of the expression? Well, the same idea. If I was going to take this, I have 1 over x to the negative fifth. I have to take the reciprocal of that, so it would now be x to the fifth over 1. But we don't have to write that part. So it will work both ways. If it's negative and it's in the numerator, like it was in our first problem, all of this is over 1, it goes in the denominator, but only the term, or only the base, with a negative exponent. So as we look at the last one, what's the simplified form of the expression? This is over 1, bada bing, bada boom, 1 over x to the ninth. We can also use this and solve, and there are two different ways to do it. It doesn't matter to me which way we do it, but you have to use the one that you're going to be most comfortable with. Some folks like to do this. They'll take 3, s is 2, so they're going to put in 2 to the third, and they're going to put in negative 3 to the negative second. So one way to do this is actually do your substitution first. So we still have some work to do afterwards. Well, this is all over 1, just for the sake of having this negative exponent. Okay, remember it has no impact on this negative sign here. So if I want to continue solving, I have 3, which stays put. I have 2 to the third, which is 2 times 2 times 2, which is 8. And it is going to be over negative 3 squared. But now I have 24 over 9, which I can reduce back to 8 over 3. Remember, negative 3 times negative 3 is going to be positive 9. So here's my final answer, 8 over 3. Now I have some other folks, and their brain wants to fix this as soon as they see it. So that's the other way to do it. So I could say 3 s to the third over t squared. So now I don't have any more negative exponents to deal with. Now substitute. So 3, I have 2 to the third over negative 3 squared, which will give me 24 over 9, which gives me 8 over 3. So it doesn't matter. Some folks don't want to see negative signs and negative signs. If we can fix this numerator, where we can fix this negative exponent, then we want to do that first. Other people are okay with it. So either way you want to try it, let's jump into the next one. So I have n is to the negative fourth, and I have w to the 0 power. Doesn't matter what w is going to be. Anything to the 0 power is 1. So I already know I'm taking 1 times whatever I have going on here. And again, some people want to see this as n to the fourth, because right now it's in the numerator. So I'd like to flip that over. So I have 1 over n is negative 2. So I have negative 2 to the fourth power. So I'm dealing with negative 2 times negative 2, which is 4, times negative 2, which is negative 8, times negative 2, which is 16. So 1/16 is the final answer. The only way I can make these things a little more confusing is to try and throw more stuff in there. So of course that's what we're going to do. So real life application, population growth of marine bacteria, so that means something in the water, doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by the expression 1000 times 2 to the h, where h is the number of hours after a scientist measures the population size. Evaluate. So here's what they want me to do. They want me to evaluate the expression for h equals 0. So I'm going to take the expression and I have to solve it for h equals 0 and for h equals -3. What does each value have from the expression of the expression represent in the situation? Well, here we go. Let's plug in 1000 times, I don't like to use that, let's put a parentheses here, 2 to the 0. Well, we know that's 1000 times 1, so it's 1000. So when h is 0, we get 1000. Now I'm going to take 1000 times 2 to the h, and this time we're going to plug in -3. So I have 1000 times 2 to the -3rd. So I have 1000 times 1 over 2 to the 3rd. Let's get some more space here. I have 1000 over 2 times 2 is 4 times 2 is 8. So 1000 divided by 8. And our 1000 divided by 8 is 1 over. Oh, I'm sorry, it's not 1 over. It's 125. Alright, so we have some clarifications. Let's run through all the stuff we did today. So if I know 4 squared is 16, if it's negative, it's 1 over 16. I've got 12.72 to the 0 power. 0 power, my answer is 1. What is the simplified form of the expression? Well, I don't have anything I can put together, so I have 12. I have y to the -3rd, so that means y to the 3rd goes down. And z to the -4th, so z to the 4th we'll also put in the numerator. Remember, 12 itself has something we don't write. We don't write a power of 1 on everything, so it stays put. So 2 is going to stay put. And c to the -7th in the denominator is going to come up. Except for now it's c to the 7th. The next type of problem that we did, where we actually used our evaluating skills, we plugged things in. So I'm not sure which way you're going to like better. So let's just do this. So 4y squared over x to the 3rd. So what I've done is I've gotten rid of all the negative exponents. 90% of the time people like to do that first. And now we say 4 times y is 4 squared over x is -2 to the 3rd power. So 4 times 4 is 16, so that's squaring it. And then 16 times 4 is 64. And I have -2 times -2 times -2 is -8. And if I divide again, I get -8 as my final answer. Then we ran into this word problem. The number of hits on a website doubles every month, so it must be popular. About 29,200 people visited the website during May. The expression 29,200, I'm going to need that. 29,200 times 2 to the t power models the number of visitors after t months. Evaluate the expression for 0 and for t equals -3. So t equals 0. So that's 29,200. Whoops, one too many zeros on there. Alright, times 2 to the 0. Anything to 0 power is 1. So this is actually 1, and 1 times anything is what it is. 29,200 for t. How about t of -3? 29,200. Look at that, I wrote it properly this time. 2 to the -3rd. So that's 29,200 divided by -8. So here we're looking at -3650. So we have answered both parts. T of 0, 29,200. T of -3, 3650. With a lesson check, I'd like you to try these before you come into class, and we can use those as starters, kind of like an appetizer. If you have any questions, we can answer it there.